Okay, perform the operation and simplify. So we can see we have two quantities, okay, both involving the letter I. These are now called complex numbers. That's complex number 1, complex number 2. And in between the quantities, we have an addition sign. So all you're doing is combining like terms. You got constant and I, constant and I. So constant, 5 plus 8 is 13. And then the I, 2 plus negative 3 is negative 1. That's your answer. Okay, now we have C1, C2 here, but now in between the quantities would be a multiplication operation. So you know what goes on there. You distribute the 5 to the 2 and the 5 to the negative 10i. It's the FOIL method, okay? So the 5 gets distributed, then the 3i times 2 and the 3i times the negative 10i. Okay, so 5 times 2 is 10, and then negative 50i, and then 6i, and then negative 30i to the second, but I to the second is always replaced with that special value of negative 1. So negative 30 times negative 1 is 30, okay? Alright, so you have constant plus blank I, or no. Okay, so now we combine them from over here. 10 plus 30 is 40. And then negative 50 plus 6 is negative 44. That is your simplification. Okay, you ain't factoring that. Just cross that problem out. Okay, find the quotient means you divide, but you can't divide if there's an I in the denominator. Okay, that's not going to work. So what you need to do, you're going to make a new numerator, new denominator where you can divide because there won't be an I there. So you need to parenthesize your numerator and denominator, multiplication by a new fraction. Now I got to decide what to put in this new fraction. Well, on the bottom here is one term. If it's just one term, you can just put an I here, and whatever's on bottom, you got to bring and copy to the top. What you're multiplying by on bottom, you got to multiply by what's on top. Okay, or excuse me, that didn't make any sense. Excuse me. If my denominator is I, this numerator that I'm multiplying by also has to be I. These have to match every time, every stinking time. Okay, now we're going to find our new top and our new bottom, which is not hard. You just distribute. It just takes a little bit of gumption. So I'm going to distribute 6 to 1i and 5i to 1i. So 6i, that's 5i to the second. So you replace your I to the second with negative 1. 5 times negative 1 is negative 5. So blank plus, so again, you're going to have your negative 5 plus your 6i. I'm not even going to draw the blanks, okay? You can't combine those. I would put that before that. Okay, now bottom. Well, this is easy. It's just 2i times 1i. It's just 2i times 1i. It's just one product we need to find. So that's 2i to the second. So you replace your I to the second then with negative 1. So 2 times negative 1 is negative 2. Okay, all right, sweet. Now the i's out of the bottom. Now you can go through and divide each of these top two terms by negative 2. So negative 5 divided by negative 2 is 2.5. Or you can write 2.5. I don't care. Now 6 divided by negative 2 is negative 3. But you got to remember that's still multiplied by I, so it's got to be negative 3i. There's your quotient. Okay, next one, you're still finding the quotient. So you parenthesize a new, remember you need to write a new fraction or division without the I on the bottom. That's what you're trying to accomplish. The way to do it is to multiply by what's called an equivalent fraction. Means the bottom, whatever I put here, that's what I'll put on top. But I got to decide what the heck to put here. Well, now this is not just one single term, it's two terms. So in two terms, you apply the conjugate rule. And that will eliminate the I from the bottom. So What the conjugate, you keep your 7 the way it is, but you switch the negative 1i to a positive 1i. Okay, the I term that we're trying to get rid of will be switched from a negative to a positive, or from a positive to a negative. So if that's what I'm putting here, I copy this to the top. Okay. Okay, so now I got to find what I'm going to have on top and what I'm going to have on the bottom. Numerator, denominator. So I take 8, 8 times 7, 8 times 1i. Okay, and then 2i times 7 and 2i times 1i. So that's 56, that's 8i, 14i, 2i to the second, replace your I to the second with negative 1, and 2 times negative 1 is negative 2. So now we combine the 56 to the negative 2, and that's 54. I combine my like terms of I, and that's 22i. Okay, and that now sits on top of the numerator. That's our new numerator, the new top. Now in the denominator, I take 7 times 7, 7 times 1i, exact same process. Negative 1i times 7, negative 1i times 1i. So that's 49, 7i, negative 7i, and negative 1i to the second. Okay, so the I to the second is replaced with negative 1. Negative 1 times negative 1 is positive 1. So I do what I'm doing here. I combine the 49 and the 1, and that makes 50. Then I combine the 7i and the negative 7i. Well, that adds to 0, so don't put anything. Don't put I, don't put anything if it adds to 0. It's just 50. Now we can execute our division. Okay. Okay, so I'll be dividing 54 by 50. Second PRB that if you want. 1 and 2 25ths. There's no variable multiplied by 54, so it's just 1 and 2 25ths, or you can write the decimal, I don't care. Then 22 divided by 50, whatever this is still has the I multiply, or is still multiplied by I. Second PRB, 11 25ths. It's positive, so you need to put a plus sign, 11 25ths. I, that is still multiplied by I. That's your answer. Okay, now we're going to be solving equations, and so the answers are going to look a little different here. So you start it the same way. Okay, you make a solution box. You have x second only. Okay. So that means you're using linear properties to solve it, followed with a square root. So there's two answers for x. Okay. This is linear properties. Okay. Negative 3 times x to the second power plus 4. Highlight the times. Take out your plus 4 with minus 4. That's 81. Okay, now take out your times negative 3 by dividing by negative 3, and that's negative 27. Now you take out your second power with the square root, but oh, we have a negative and a square root. Now some of you are like, how do you take the square root of a negative? There's nothing times itself that equals a negative. Well, there's going to be eventually. Okay. Domain error. Here's what you do with the domain error because you have a negative and a square root. You can make it positive if you poke the letter I out. Okay. Now, so I'll square root the 27. That's irrational. That's IRR. Okay. So what we need to do with an irrational square root, where I get this decimal that just goes on forever, we need to put a division sign, we need to put a parentheses, and then double square roots. So I go 27 divided by, okay. Got to be one of these perfect square root numbers, okay. Divided by 25 doesn't work. 16 doesn't work. 9, you put 9 and 3, not because it's 9 and 3 here. That was just by accident, by dumb luck, a 1 in a million. So 9, 3, fill the square roots. 9, 27 divided by 9, and its quotient of 3. So the square root of 9 then becomes 3. Now, this I goes between the whole number and the radical number. So the answer is, remember, a square root could be positive or negative, 3I square root 3. That's what you put over here, as a positive and as a negative. Okay. Let's do another one. 5x to the second power plus 2 equals negative 58. So you have x second only. So again, it'll be linear properties followed up with a square root. Okay, so there's two answers. Multiplication by 5 and then plus 2. Minus 2, that takes you to negative 60. Divided by 5, divided by 5. Negative 60 divided by 5 is negative 12. Okay. So I take the second power out. Okay. Remember, this could be positive or negative, but I can't square root negative 12 with that. It's a domain error. So you've got to poke the I out, and then you can worry about the 12 being positive. Square root of 12, that's IRR. So when you get an irrational square root in the linear properties square root, you need to put divided by and make your two square roots. Okay. So 12 divided by 9, divided by, it ain't going to divide by 9, it does divide by 4, but you don't put 4, 2, you put 4 and 3. 4 is what I'm dividing by, 3 is what 12 divided by 4 is. The 2 comes in when I replace the square root of 4, and that's equal to 2. Then you've got to put the I in between because there was an I had to poke out. So 2I square root of 3. Okay, next problem. Negative 6x to the second power plus 2 equals 218. Okay. So you have x to the second, okay, only. Okay. So that's linear properties followed by a square root. Okay. So there's two answers. Okay. So you minus 2, that's 216. And you divide by negative 6, and that's negative 36. So remember, x could be a positive or negative whenever I square root it. You need to poke the I out. Now this is not going to be an irrational square root since the square root of 36 is 6. Okay, so I just put 6. Put the I after it. You don't have a radical. So it's 6I and negative 6I. X to the second power plus 25 equals 0. So two answers. We have x second only. So again, it's linear properties. Follow that up then with a square root. So you don't have to do, all you have to use minus 25, and that'd be negative 25. You don't have to divide here. Now you just get rid of that. Okay, so x could be positive or negative. You poke the I out, and the square root of 25 is not irrational. It's 5. Okay, so 5I. Now the reason these are your answers, don't write this down, but the reason they're your answers because x to the second equals negative 25. Well, that means what number times itself is negative 25? You're like, oh, it doesn't exist. Not in the real number system, but in this number system, the complex number system, it does exist. Because if you take either one of these, I'll pick the negative 5i. I'm just picking one of the two. and take it times itself, because if x equals this to the second power is this times itself, would be 25i to the second. But I to the second is always replaced with -1, and that's -25. Okay, so that's how you can get that. All right, now in the next page of problems, I accidentally wrote on the next one. Let me find it in the blank one. Okay, 4x to the second minus 3x plus 5 equals 0. Now, we have x to the second along with x now, so we have to apply the factoring properties. Now I'm going to shorten this a little bit as to the method to use. So there's two answers. Factoring properties, you still got to have your 0. You still got to count the terms, there's 3. So it would be GCF and then your table. So no x, no negative, 1 would be the GCF. 4 times 5 is 20. I'm here to tell you today the table doesn't work on any of these. They're all QFs, okay, just to save some time for you. Okay, opposite of b, plus or minus the square root, b squared minus 4ac, b squared minus 4ac over 2a, over 2a. So positive 3 is the opposite of b, and then b, -3. 4ac, so it's 4, and then 5, and then a on the bottom is 4. Okay, so you have 3 in front, 2 times 4 on bottom is 8. Now you evaluate that the same way, but you're going to have to change something here. -71. Well, you're going to have to poke the I out, and then when you poke the I out, you're still going to square root it on a calculator. But now you can't put that 8.43. Okay, if you poke the I out, I don't want you doing that. I'm sorry, but you're going to have to do the IRR label followed by the division and then the double square roots with the I going in between. Okay. Okay, so 71 divided by 64 decimal. 71 divided by 49 decimal. 71 divided by 36 decimal, 25 is a decimal, 16 is a decimal, 9 is a decimal, 4 is a decimal, and 1 gives me 71. So I put 1 in 71, and the square root of 1 turns into 1. Now you want to keep the 1 there if there's an I in between. So 1i square root 71. So if you're using the quadratic formula and you have to poke the I out, this is how the square root needs to be simplified. The IRR label, the division, just like you do on the linear properties. So how you write that, you don't add or subtract anything, okay? You can't. Because first off, how am I going to add 3 to this crap? I can't. So I put 3 plus 1i square root 71 over 8. And then 3 minus 1i square root 71 over 8. Okay, next problem. 7x to the second power minus x plus 12 equals 0. So I've got 2x second and x, so that means you're doing your factoring properties. So 0's there. There's 2 answers, by the way. There's still going to be 2 answers. So 3 terms. So GCF. And table. So 1 is your GCF. So 7 times 12 is 84. But again, I just told you you're not going to be able to factor this into parentheses. You'll never find the mystery numbers you're looking for. QF. So opposite of b, plus or minus the square root, b squared minus 4ac, b squared minus 4ac over 2a, over 2a. So the opposite of -1 is +1, and then -1, and a is 7, c is 12, and then a on the bottom is 7. Okay, so you got 1 in front, 2 times 7 on bottom is 14. Now you line up that square root, okay? Negative 335, well, hello, I, okay? So the difference between this and the regular quadratic formula problems is you are not going to put that decimal because there's I there. You need to label it IRR because it's irrational. That's what that means. That's irrational. It means it just goes on forever. You put the division sign, you put the two square roots in parentheses with the I in between, okay? You're just going to drop that down there. Okay, because I doesn't just go away. I can't just square it into a decimal because then I'm forgetting about I. So this is how you need to simplify it with the I. Okay. This one's terrible. It doesn't divide by anything. It's all decimals till you divide 335 by 1. 1 and 335 again. Square root of 1 is 1. So 1I square root 335. Okay. And that's what you put. 1 plus 1I square root 335 over 14. Remember 2 times 7 was 14. Then I just switched the plus to a minus and it's the same thing. That's how those answers need to be written. Okay, next one. X second plus 4x plus 5 equals 0. So you have x second and x, that's applying the factoring properties. So there's two answers. Zero's there, so 3 terms. I've had people argue with me in the past on this problem here. One's a GCF. They're like, 5, positive, that'd be a match. Can I add to 4? Match, you put do double negative or double positive. No, you can't. 5 divided by 1 divided by 1 is 5. That's negative 6. And then you don't get anywhere until you're back to 5, which I already have. So again, I said QF on all these. So opposite of B, plus or minus the square root b squared minus 4ac, b squared minus 4ac over 2a over 2a. So opposite of b is negative 4. Then b is 4 to the second. Then a is going to be 1, c is 5, and then a is 1. Okay, so you have negative 4. 2 times 1 on the bottom is 2. So 4 to the second minus 4, 1, and 5. Negative 4, you're going to poke the I out, but you don't have to do the IRR label because the square root of 4 is 2, okay? So you bring 2 down here and you got to place I behind it, okay? That's not IRR. I square rooted it. I didn't get an irrational number. I got a whole number. I got 2. 2I. But you're still not adding and subtracting. This has I, this does not. So negative 4 plus 2I over 2, negative 4 minus 2I over 2. Now, if I wanted to be a real crazy teacher, I would make you reduce all these numbers. 4, 2, and 2, all reduced by 2. So if I divided them all by 2, all of them, it'd be negative 2 plus 1I. And there'd just be a 1 on the bottom, so we wouldn't need it. And this one would be negative 2 minus 1I. But just get me there, and I'll be happy. Okay, 3x to the second power plus 1x plus 2 equals 0. So we have x second, we have x. That's factoring properties. Zero's there. GCFT. Okay. Again, I just said the T wasn't going to work. GCF's 1. Okay, so opposite of B, plus or minus the square root, b squared minus 4ac, b squared minus 4ac over 2a over 2a. So here's my ABC. Opposite of positive 1's negative 1. B to the second, so it's 1 to the second minus 4, 3, and 2. And A here is 3. Okay, on the bottom, 2 times 3 is 6. Enter that in. 1 to the second minus 4, 3, 2. Got negative 23, so what do? Well, got to put the I, and when you put the I in the quadratic formula, unfortunately, you need to square root it. Well, that's an IRR. Okay. Now, if the I wasn't there, I'd be putting 4.80 and going about the business, but with the I there, you have to label it IRR, put the division sign. IRR stands for irrational number, okay? Irrational square root. Then I put in the 2 square roots with I in the middle. That's why we have to do this, because of that stupid I, okay? So we put it in the middle, and I start dividing. 23 divided by 16 is a decimal. 9 is a decimal. 4 is a decimal, so I guess it's going to be just 1 and 23. Square root of 1's 1, 1i, square root 23. And then you don't add or subtract nothing. You just line it up the way it is, sits right there. Negative 1 plus 1i, square root 23 over 6. Negative 1 minus 1i with the square root of 23 over 6. Now keep in mind, the square root of 4 on the last problem is not irrational, it's 2. You put 2 with I behind it in that instance.